Hi there, and welcome to Mr. Carlson's lab. In a previous video, I repaired a switch mode power supply that came in a box of parts. Now, this box of parts really is a disassembled Tektronix TDS 424-channel oscilloscope. Now, I managed to resurrect this power supply. Even the power supply was taken apart in that box, but all the components were there. I'll link that video in just down below. If you click on the Show More tab just below this video, I'll link that in right there. So I figured since I got this switch mode power supply working, why not try and get the rest of the oscilloscope working as well? So let's get started. These are the parts that I got with the part scope. There's a few parts that aren't in the shot right now just because I can't fit them in here, but I'll show you those in just a second here. So there's a little bit more to this story. I went to go get an oscilloscope that was like this one behind here, the TDS 350, and this one here just came as a parts machine for it. So basically, you know, I could use the monitor, you know, the CRT, the yoke, maybe the board in there, maybe the fan is good or something like that. It just came as a parts unit. So when I originally took this was shoved into its case, and this is one of the things that won't fit in the shot here. So this is the case right here for it, and you can see it's missing the handle, and it has no feed on it or anything. And it basically is just a square box. And when I brought this thing back home, of course, you know, having the case on it and everything, I didn't look inside. So I got it home and there were no boards inside, which are these three boards here. So I phoned the fella back that owned the scope, and he's a really nice fella. And I said, hey, would you mind looking around for those boards? I said, I can't even try to put this thing back together or, you know, troubleshoot it or anything, and it would be nice to have those pieces just as spare stuff. He said, sure, I'll go look around. So he calls me back and he says, yeah, I found three boards and a little jumper ribbon, which is this here. And he says, yeah, you're welcome to come and get it. Well, I live an hour away in one direction from this guy, and I figure, is it worth it? Okay, I'll go back and get them. You never know. Maybe this will be worth it. Maybe not. I'll just gamble. So tonight we'll find whether that gamble pays off. So this is pretty much how it is here. I'll move the scope and the boards out of the way in another shot here. I just want to, you know, move the camera around and stuff like that. It's kind of hard for me to get in front of the camera here. So what I'll do is I'll move all this stuff out of the way, and we'll take a little closer look at the actual scope itself. Just before I reposition the scope, let's take a quick look at these boards that have been rolling around for who knows how long. These things may have even seen some carpet, so hopefully they haven't been zapped. So this here is the video board. I still have to find out which slots are which in the back here. So there's a bunch of open slots, and these just slide in. So I have to figure that out before I plug all these things back in. And everything's got to kind of line up here. This here is the CPU board, or processing board right here. Again, who knows if this thing has been, you know, turfed in the back of a car on carpet, or been, you know, how long it's been out of the machine and rolling around. So your guess is as good as mine. And this here is the digital signal processing board right here. So they look to be in fair shape. Like, the boards themselves are in very good condition, and whether they've received any static or anything is yet to be found out. So those are the three boards there, and then here's that little ribbon cable that was turfed in the pile with them. So I'll just move all this stuff off the bench carefully, and I will reposition the scope, and we'll take a look inside that. We're now looking at the bottom portion of this oscilloscope. So this is the front end here. This is where all the probes connect to on these BNC jacks. All right, you can see that this board here is connected through an interconnect to the acquisition board, which is right here. Now, these old TDS 420s are known for having bad capacitors, and those capacitors are everywhere. So guess what? We're not going to change any of them, because that would take away from the fun. This is a junk box oscilloscope, so let's just leave it like that. The only thing that really is done is the power supply, and that was in a separate video, just to do basically a video on the switch mode power supply. And reviving this old oscilloscope was really a last minute decision. I figured, you know, let's do it. Let's try and make this thing come back to life again. Let's see if it'll happen. So I'm not going to change any caps on these boards or anything like that. And that will really be a testament to how tough this oscilloscope really is. If it comes back to life with all those other boards rolling around, you know, in a box, who knows if they've seen carpet time. So yeah, this should be very, very interesting. I'm looking forward to seeing if this thing even turns on. So that's the bottom portion here. So next I'll flip this thing over and we'll take a look at the top side. Here's the top side of this oscilloscope. See all the ribbon cables hanging out here and all the wires are all undone everywhere. Looks like there's some black tape on here. Hopefully none of the lines are broken under here. Thankfully, Tech put this little blue strap here, and that's holding this completely free ribbon wire in here. I can pretty much guarantee if that little strap was in here, I would not have this ribbon wire. It'd be gone. I was lucky enough to get the boards back in that little jumper. So, you'll notice that when I'm bending these over, I'm not bending them on a sharp angle. This one here has been bent on a sharp angle, and if you kind of let it go back to the way it was, you can see here, this board looks like it connects to this interconnect right here. A lot of the times, these are bent at the factory, so when you let them free, they kind of almost fall into place. They'll almost hit the connector themselves. So that's a nice little hint whenever you're trying to put something back together. Just kind of follow the natural flow of things. So the monitor here is still all really dirty. I haven't really cleaned anything up. You can see all the dust and debris on it. This dirt on the picture tube. Look at all this fuzz on the wires down here. So I haven't cleaned any of that thing up. Again, of course, right out of the junk box, right? So this is where the mains comes into, and there's a filter in here. It looks like there's a little bit more filtering on this board down here. There's a big inductor down here, and a switch on the back, and a bunch of other small inductors, and the fan would most likely plug into where it says fan power, so probably into here. And that socket says CRT power, so I'll have to figure out where all of these things tie in here in a moment. There's a little white wire that's also hanging loose. Here's where that power supply, that switch mode power supply that I just rebuilt, will fit. You see this big connector that goes to that row of pins. This would be where the mains comes into it. So it just looks like it snaps in here on these clips here, so basically you push it in and snap. It appears to be the way things will go. It's a fan spin, it does. Looks like it's been hot though. Look at the bearing, it's got this nice little brown stain on it here. Either hot or maybe some oil, but that looks more like heat to me. That's more of a burning looking color there. All the dirt on the CRT, can you see that in there? I don't know if you can see all the dirt on the CRT in there. Yeah, it definitely needs to be blown out with a compressor or something like that. So that's the top side of the scope. See over here, this is where all the boards plug in. We see 3 empty slots here, so that's a nice little hint that that's all that was in here. These are plugged off, and it doesn't look like these have been used. If you look at the actual connectors here, you can see the pins have been pressed apart a little bit on these 3, and these are all touching together. So these are relatively fresh, and you can see these ones have definitely been used. So that's a nice clue that this thing only had 3 boards. This would obviously be for that little ribbon cable that comes from the bottom here. So it'll jump up to a bunch of boards. It'll also help in identifying where they go. Just a row of linear regulators here, some capacitors and some inductors on a board here. Another interconnect here. You see that interconnect down there? Another one down here. So, and this one here is interconnects to something. So all to be figured out. And that will be the next step. The first thing I'm going to do is put the switch mode power supply back in. So this is the power supply that was rebuilt in the last video. Again, that link will be down below under the Show More tab. So this thing will go in first, and it has to go on this side here. So what I'm going to do is just move the scope around here, get it positioned a little bit better for the camera, and I'll snap it in. I've got the scope on its side now, and I'm ready to put the switch mode power supply back in. So hopefully this goes easy around the tripod here. Making sure no wires are tangling up anywhere. It's a pretty tight fit to get this thing in and out of here. Set that on top there. And it looks like on the bottom here, this is going to have to slip right into those little, there's like little clips on the bottom down there. Like so. Is it in on the other half here? It doesn't look like it. There it is. Okay, and looks like it'll just snap in now, like so. That wasn't so bad. So we'll look at the mains connection here. And this big long connector here has to go on. Nice rigid wire there. One thing about these connectors you got to be really careful about is that if you put these things on, you can misplace them by a pin, and that will cause some really bad damage. So you really need to make sure that this isn't sitting one pin out either way, because it will miss that pin. You can completely miss a pin on the bottom or a pin on the top here. And what I mean is, like, you can put this accidentally down like that and leave this pin open here like this. You see that? So you can put this connector on the wrong way and leave that pin open. So you want to definitely make sure that you have them in the right position. It's a common thing. I've seen it done a lot. Alright, that looks like that's on, nice and solid. So obviously this here connects to this here. That little connector is connected in there like so. So what I'll do is I'll turn this on another angle here and get a little better shot of the other ribbon cables. These ribbon cables almost give themselves away to where they're supposed to be plugged in just by the way that they're bent at the factory. We looked at this one earlier and we can tell that it obviously plugs into the board down here. So I'll just push this into the slot here gently. I'll cinch these up here in just a moment. So I'll just push that in there for now and I'll cinch that up in a little bit. So this one, you can see, goes right in line. There's no bends. And you can see this one has another one of those sharp bends. So obviously this is going over like this. Alright, so if we get the fan wire out of the way, we can see that this falls right into this little CRT plug down here, and this plugs in right here. So these don't go in very easily, and you really don't want to use the wires to force them in. You want to use the plastic connector because these are kind of frail, so you don't want to do that. So this one here will just snap into the little socket down here. Again, I'll just tighten these up off camera. So that's pretty much that, and the fan plugs into the little plug right beside it there. Goes this way, I think. There we go. So that just plugs in like that. Not too worried about tying this stuff up right now. Again, let's just see if the thing even starts up. So that's that for the ribbon cables in this area. All the wires look like they've been reconnected in this area. So now we'll go on to the other side and install the boards. I found a service manual online for this TDS 420. It's in PDF form. And they're nice enough to show where the boards go. Now, if you're planning on doing any kind of board level troubleshooting in any of these newer Tektronix oscilloscopes, don't get your hopes up unless you have a part scope. Reason being is Tektronix really doesn't release a lot of information about these things. Really, they're telling you how to replace boards and play with things in the menu and things like that. So that's one of the things with these newer Tektronix oscilloscopes. So if you really want to play around with one of these things, if you're going to try and troubleshoot something that's dead, it's good to have a part scope around or something like that. So since there's options available here, they clearly show where the boards fit, and that's kind of nice. So it kind of goes small, bigger, and then biggest, which is DSP board, video board, and then the CPU board. And it also shows that this ribbon wire tucks around here, so it kind of gets pinched up against these capacitors here. So I'll slide in that CPU board. Alright, and I'll just press it into that connector there. And it's in. And we can clearly see that this connector here lines up with this right here. So I'll just plug that in. Kind of hard to get my hands in here. Imagine if I put the lower boards in first. There'd be a lot of grief to get that in. All right, it looks like it's almost in. There we go. All right, so I'll slide in the next one, which is the video board. You want to apply nice even pressure when you're doing this. Should just gently kind of rock into place. And again, we can see that this connector just really falls into place with this right here. Nice and easy. All right, and the last board here is the DSP board. See, you would almost want to catch on that there. Again, this should just gently rock into place, like so. Looking good so far. Now we can see this little ribbon wire here. One's spaced a little further away than the other, so you can see that this is further away than these two. So that's pretty easy to figure out. Press this in a little bit. There and there. And once you get them all lined up, you can just press them all in. All right, so I'll go through and make sure that all the connectors are nice and tight, and we're just about to the point to where we can turn this thing on and see if it'll actually fire up. All the circuit boards are installed and the ribbon cables are all connected, and I'm ready to give this thing some power. So I have this thing plugged into my isolation transformer, and there's a switch on the wall that turns that whole system on. I've checked the fuse in the back side of this oscilloscope. It's a 5 amp fuse, and that's what it calls for. There's also a switch on the back that piqued my interest. I was wondering what that was for, and that's just an auxiliary on and off switch. So I made sure that that was in the right position. So I'm ready to turn on the power and see if this thing does anything. So I'll just shut the light off here. You see all the dirt on the screen? I didn't even clean any of that off. So I'll turn the light off, and if anything happens on the screen, it'll make things a little bit easier to see. So here it goes. Switch on. I don't know if I should run and duck or whatever. Okay, here we go. Oh, starts right up. LEDs are glowing, and I hear a really noisy fan. Oh, listen to that fan. Hey, the screen's lighting up. And there's a clock symbol. It's 9 o'clock, it says. That's doing some interesting things. The waiting is the hardest part. Sounds like galloping relay horses. Oh, well, it says diagnostic log. What do we got going on here? Pass, 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 fail. This is plus plus DSP. And it looks like everything else is a pass. So I'll clear the menu here. And it starts up. Looks like everything is working. So that's a good sign that all the inputs are working. Didn't have any other failures there at all. So it just says that there is a DSP issue, and I kind of have an idea what that probably is. So what I'm going to do is reposition the oscilloscope here, and we'll take a look at that one little area. The oscilloscope is back on its side again, and you'll notice on the DSP board that there's a connector here and no wire is going to that connector. And there's also the same connector on the CPU board just behind this connector here. And those are for RAM batteries. You'll see these two clips right here. There's a clip right here and a clip right here, and that's to hold those two batteries. So what I'm going to do is put some batteries together and hook them up to these two connectors here and see if we can get rid of that code. Since the RAM batteries weren't included in this pile of parts that I got with this oscilloscope, this posed a bunch of issues. One of the issues being I don't have the original connector to plug into the circuit board from the RAM battery. And secondly, I don't even know the polarity of that plug. And it's amazing how little information there is about that. Now, I searched the internet for a long time trying to find just a picture of that plug. Now, I had an idea because I probed the 2 pins with my voltmeter. I got an extremely low voltage in the positive direction. And then, of course, if I removed the probes and reversed them, you know, I get the minus symbol and extremely low voltage. So I kind of had an idea, and that's, you know, a pretty good way to tell. But, you know, I want to be absolutely sure. I don't want to, you know, destroy this board. So, cruising around on the internet, I found a picture somebody had taken of just the front end of a like RAM board for a Tektronix oscilloscope, and it had the connector clearly in sight with the red and black wire, and even showed a little bit of the RAM batteries in the background. So that was comforting, and it, you know, coincides with what I found with my voltmeter on the actual pins on the board. So now, another problem is I have to make a small connector to plug into this thing. So I've got a bunch of these push-on connectors here in a bag. I've actually got quite a few of them. I don't know if you can see that. Very small push-on connector there. And that'll fit tightly on the diameter of the pin. So what I did is soldered some wires to them and put some heat shrink tubing over top, 2 layers of heat shrink tubing. And that actually acts kind of as a springy surface and really holds it tight on top of, you know, just the actual tension of the connector itself. So this should push on really quite tight. And there's just 2 wires. So that should work very well. Since I know the polarity now, I'm ready to actually hook up some batteries. But first of all, I actually need some batteries to hook up to this thing. And in the next shot, I will show you how to solder to some batteries without causing any damage. So what I'm going to do now is give you an example of how I connect the wires to just a lithium battery. You can see that it's soldered on the back side here, and it's soldered on the top side here. This one's already done. I have to do 2 because this needs 2 batteries. So a lot of people frown on soldering to batteries, and they say this, that, and the other. And I personally have never had an issue with it. I'm not one to just take somebody's word for something. I go in and I experiment and try myself and see if I have any issues. And I've been doing this for, I don't know, 20 years now, and haven't had any problems with a battery. And there's a trick behind it. And you need to know what you're doing if you're doing this. So if you're following along, you're doing so at your own risk. This is my own personal way of attaching wires to batteries, and there's no real rocket science behind this at all. But it works quite well. And the batteries, they seem to last and last and last. And to tell you the truth, they say soldering the edges of a battery is hard on the battery. Well, I would think that putting a little bit of heat on the end of the battery is a lot easier on it than spot welding to the surface, because that's what they do. They spot weld to these surfaces when they put the tabs on. So I've seen lots of these batteries flat in a very short period of time. Whether that's the cause, I really don't know. But all the batteries that I've done in this manner seem to last and last and last. This one here has a date of 08-2025, I guess is supposed to be the expiry date of this. And something that's even more impressive about this cheaper Panasonic battery is it says, I don't know if you can see that. Maybe I can get a light on that here, because this is worth seeing. Really, it is nowadays. This is really worth seeing. Made in the USA. How often do you see that? So it's got to be good. All right, so here we have a battery. And in order to solder to the surfaces of a battery without causing damage, what I do is I have a dampened cloth. All right, so this is a damp surface here. All right, and what I'm going to do is rough up the surface here just a little bit with my old tattered piece of sandpaper here. All right, so I'm just going to take this and rough this surface up. Like so. All right, maybe give it just a little bit more. Like that. And on this side of the battery, I'm going to do the exact same thing. Okay, now the trick is I use really high heat very fast on this. So in order to solder a lead to the positive side here, what I'm going to do is put just a drop of RA type flux on here. All right, and I'm going to use my Weller gun with my shortened tip on it. I did a video on this tip here, and I'll include that in the show more. If you go just below this video, you'll see a show more tab. Just click on the show more tab and you'll see the Weller soldering iron mods video. So what I'm going to do is I'm going to heat this up and I'm going to let this get hot first, and then I'm going to put a ball of solder on the top of this. So now it's going to get hot. The ball of solder is there. And just cool it off. You can see I can put my hand on it. It's just lukewarm. Absolutely lukewarm. And there's absolutely no damage to the plastic or anything around it. So it takes a little bit of finesse. So now that that solder's on there, it's all in the preparation, okay? So now that that's on there, what I'm going to do, again, because you don't want to do this all in one shot, because sometimes it's hard to get everything happening in one shot, so I do it in 2 steps. So now that that's there, I've got my wire here, all right, and I put another little drop of RA flux on there. The RA flux is very important to make this flow out properly and to make everything stick. So I'll heat this up again. Stop. All right, it's solid. Down here, cool it off. Look at that. Barely lukewarm on my finger. Barely even warm. No damage to the plastic at all. Nothing at all here. And the same goes for the back side of the battery. I'll do the back side of the battery exactly the same way I did this. And I'll put the little negative terminal on here and this will be ready to go. So again, this takes a little bit of finesse and maybe a little bit of practice. So if you haven't done this before, you know, maybe experiment on some dead batteries. Of course, it's your own risk. You need to know what you're doing. But this is how I've connected, you know, connections to batteries for years and years and years, and I have absolutely never had a problem with the battery. They don't seem to leak or anything like that. Just in case you wanted to see me do the back side of the battery here, I'll do the back side as well. I'm not sure if I'm going to include this in the shot just to try and keep the video short, but I may include this, so we'll see what happens here. Okay, so here I go. No problems. That's the flux sticking to it there. So you can see it's not even lukewarm really at this point. All right, have that ready to go. This wire is being a little bit unruly. So there we go, that'll hold it steady. Okay, another dab of flux here. I'll just see which way I've got the wire coming off. I've got the wire coming off that way. I try and align the wires. I don't want one wire going this way and one going this way, so I have to loop it around. So make sure that the wires are somewhat aligned. All right, and I'll come in from this side here. And there it is. That's the back side of the battery right there. You see the wires are somewhat aligned. Then what I do is I take just a little bit of lacquer thinner. A little bit of lacquer thinner right here. On a Q-tip. And I just clean this up. So that's the back side. And that's the top side. I can see that here in the light. So that's what it looks like. And the back side here. And it's just as easy as that. Now all of these batteries, they come out reading actually about 3.240, I think was the last one. I think this one was about 3.24 something or other. All right. And one really good thing to do is to check these once you've done that, just to make sure that you haven't damaged the battery if you're trying this. And you obviously don't want to plug those little holes in the cap. You want to keep the solder ball right on the top. You don't want to flow it out around the sides. And if you've damaged the plastic, I would strongly suggest that you replace the battery. Or if you've melted anything on the bottom side here, again, I strongly suggest that you would replace the battery. Again, if you're doing this, you're doing so at your own risk. The RAM batteries are installed in this oscilloscope and all hooked up, and I'm ready to try it out. So if you have a TDS 420 and somebody's removed the RAM batteries, one very easy way to tell its polarity is if you look at the socket, it's got two leads that come up through the circuit board and they're soldered on the circuit board. There's a square pad and a round pad. The round pad is the positive and the square pad is the negative. So that'll make things a little bit easier for you. So when I'm looking at this DSP board, the positive lead is the lead closer to me and the negative lead is the lead closer to the other side of the oscilloscope. All right, and I'm ready to see if I can clear these error codes. So let's turn it back on and see if it starts up. Okay, the power is on and it's not starting. Not like it was before anyways. So let's see if I push the on button, if it's going to start up here. Yep, there it is. Just turn off the light here, a little easier to see the screen. Wait for the galloping relay horses. There they are. Okay, so we still have failed DSP, so we might need to clear that. Okay, so I'll hit clear menu here. Alright, and I'll go to utility. Alright, let's go to TechSecure erase memory. We'll go to diagnostic and error codes. Okay. Alright, and we'll hit OK. Alright, that loud beep's got to mean something. Alright, let's get rid of that. I'll just shut it down, wait for a second, and restart it again, and see if that code is gone. Alright, here we go. Waiting is the hardest part. Look at that. Passed. So I'm on the right track. Everything is working good with this oscilloscope. So what I'll do is I'll hook some probes up to this here in just a moment and we'll try out the channels. Alright, we're ready to try out the oscilloscope. It's passed its power on test once again, no problems there. So I've got the probe hooked up to channel 1 here. I'll just hit clear menu. There's a lot of noise in here right now just because of course the the scope is completely open, right? You can see how much noise just comes from the screen itself. And I haven't recapped it yet as well, so I'm sure that will improve things. So I'll just clip the probe compensation on, and channel 1 looks like it's doing well. So let's get some measurements in here. Let's just try, say, frequency. Yeah, 1 kilohertz. And let's say, what do we try here? Let's just try peak to peak, whatever. No problems. Looks like everything's working well. So that's channel 1. Let's try channel 2. Waveform off. Channel 2 on. Trigger menu. Channel 2. No problems. Let's waveform off. Let's try channel 3. I'm doing this around the tripod, so pardon me if I'm bumping it. And we gotta go trigger source channel 3. No problems. Shut the waveform off. Let's try channel 4. Channel 4 on. Trigger on channel 4. Looks good. I think I have a winner. Or I have some horseshoes. I think that's probably more like it. So what I'm going to do now is I'm going to end up recapping it. I'll just do that in my spare time. And clean the thing up and clean the case up, maybe try and find a handle for it or do something like that at any rate. All in all, it worked out very well. It's a completely functional oscilloscope and it's, yeah, works great. I'm impressed. Not bad for something that was just absolutely considered scrap. Thanks for stopping by the lab today. I hope you enjoyed the repair of this Tektronix TDS 420 oscilloscope. If you did, you can let me know by giving me a big thumbs up and hang around. There'll be many more videos just like this in the very near future. And if you haven't checked out the previous switch mode power supply video, don't forget to do that. Just click on the Show More tab below this video and check it out. All right, see you next time.